Okay, excellent. So far, we learned about the simple linear regression. We predicted the dependent variable y with a single regressor, x. It is time to level up now. We said that in real life, a person's income does not depend solely on education, but also on their experience, the time they have spent with their current employer, and so on. House prices do not depend solely on their size, but also on location and year of construction. College GPA cannot be predicted solely by a student's SAT score, but also by their high school GPA, income, gender, and so on. If we want to make good models, we need multiple regressions. Multiple regressions address the higher complexity of problems. The more variables you have, the more factors you are considering in a model. In the real world, things depend on 2, 3, or even 10 or 20 factors. Alright, so this is the population multiple regression model. It is similar to a simple regression. The main difference is there are a bunch of independent variables, not just one. What we are interested in is the multiple regression equation. We want to plug in numbers and predict outcomes, right? Once again, y hat is the inferred value and b0 is the intercept. The independent variables range from x1 to xk. b1 to bk are their corresponding coefficients. The last thing to say about multiple regressions is that it's not about the best fitting line anymore. Actually, it stops being two-dimensional, and when we have over 3 dimensions, there is no visual way to represent the data. So, if it is not about the line, what is it about? It's about the best fitting model. As we saw from the OLS, what we really want is the least sum of squared errors. Alright, so how do we decrease the model's error? Well, by increasing the explanatory power of the model. SSE and SSR are like communicating vessels, remember? Each time we lower one, the other goes higher. With each additional variable, we increase the explanatory power by 0 or more than 0. We cannot lower it. More variables usually equal a better fitting model. In the next lesson, we will see how to determine the optimal number of variables to use. Thanks for watching.